David Dodge, CSI CDT, Vice President of Business and Code Development for the McKeon Door Company. He has been involved in the construction industry since 1975, with an extensive background in project estimating and management and a bachelor's degree in business management. David soon realized a great deal of success in building product marketing and sales. Within this venue, he found his passion, building code development and architectural design compliance. Since 1988, he has assisted architectural firms in understanding and implementing the provisions of model codes as they pertain to fire and life safety. His particular focus is on the fire door industry, promoting cutting-edge technology to resolve code compliance challenges. And without further ado, David Dodge.
Well, what are you doing here on a Sunday morning? I'd like to know that too. Listen, I'm happy to be here. It's going to be fun. I hope for 2 hours, as Rhonda mentioned, she just can't wait to hear about all this advanced code. I got it. It makes sense, but hopefully we'll be able to have some fun with this. So, on the tables as you came in, there's a booklet. Wendy's holding that up. So if you didn't grab one, or if you got one at the show and it's in your room or whatever, raise your hand so we can give you one of these now, because you're going to need it during the presentation. So if you'll raise your hand, they'll start passing these out. And while that's going on, let me give you a little bedtime story that will have this all make a little bit more sense. I apologize if a few of you may have heard this. Just hang on, because I think most haven't. So way back in the ancient of times, in 1988, as I embarked on this concept after 17 years of working in the construction industry. By the way, can you hear me okay? We're good? Okay. Embarking on the construction industry and being involved, and quite frankly, I was one of those guys. You know who I'm talking about, the infamous general contractor. You with me? Yeah, I was one of those, and I spent 17 years, built just about every building that there was. It was a great ride, and for several reasons, I switched horses, mainly because of two issues. One is it seemed like construction was getting so ridiculous and litigious. Does that ring a bell? It just seems like all you did is cover your tracks all the time. But number two, my wife and I had two little toddlers that were growing up. We didn't want to move them all around the world wherever we were going to the next job. I decided to jump into the dark side. I jumped into the manufacturing side. So I found myself in 1988, June, after 6 months into my tour with this new company, I find myself in Santa Barbara, California. Does anybody know where that is? Okay. Where are we? Oh, we're in Florida. Okay, I got to hang on. I travel so much, I'm not sure where I'm at. So what happened was I had this appointment with a very small architectural firm. Great bunch of folks, and I remember, just to set the setting for you, I remember that I'm driving up there in my car, and guess what I have? I have this brand new technology. It's this brick cell phone in the center of the console, right, with a curly-Q antenna that makes you look like a real stud muffin as you go down the road. Remember those days? Yeah. And so I just got that, so I didn't have to stop at payphones. I just got permission to buy a carousel projector, 35 millimeter slide projector, because I had a total of 4 photos of this new technology, and I wanted to show it to the architect. You with me? So yeah, when I do that famous vendor dump, you know all about that, right? So I have all this stuff, but what was most exciting was my brand new fax machine that had thermal paper. And it came in a roll. Remember that? Yeah, so that's the time frame. I'll be 70 in December, by the way, so that ought to give you a little bit of an idea. All right, so I walk into this firm, and the first thing out of the owner's mouth, the architect, was this. Dave, he said, thanks for coming. I'm glad you did. But he said, I really don't have anything for you to look at. Oh, okay, cool. Well, I've got all this widget that's you need 9,000 of them. Don't tell me you don't want to listen to my spiel, right? So anyway, he said, I just finished a little 3-story hospital. I'm going to turn it into plan check on Monday. So he said, since you're here, he was very kind. He said, since you're here, you want to look at that project with me just for fun. So I took off my vendor hat, put on my old contractor hat. He took off his host of vendor hat, and he put on, I'm going to show off what I did with this design. Great. So we sat down, laid the drawings out on the conference table. We start flipping through the drawings, and as he's flipping through the drawings, it was creative, it was great, but let me ask you, what is the minimum corridor width for in a healthcare where you have suites of sleeping rooms? What's the minimum corridor width? Anybody, shout it out. Yeah, it's 8 feet. In a 3-story hospital, he had no 8-foot corridors. They were all 6 foot or less. Now, remember, I had a contractor's knowledge of the code at the time. How dangerous is that? Right? But I'd build enough of those buildings, you know what? I was that guy that always said, hey, I really don't care what your problem is. Just get it resolved and get me back on schedule. Come on, chop, chop, right? I wasn't paying attention to what was going on down in the weeds. So when these problems would come up, did I explore the code and deal with it? No, I just want to get this project on schedule. I don't really care about anything else. So that's my perusal understanding of the code. But I'd build enough hospitals I knew you had to have 8-foot corridors. Secondly, at what point do we have to compartmentalize in smoke compartments? 22,500 square feet, right? As soon as you hit that magic number, compartmentation kicks in over and above the 5,000 foot stuff and all the other. But I didn't understand all that. I just knew that every time you cross a corridor with a wall where you have the 22.5 rule, you got a pair of dual acting swings, right? That's what they're there for, because they were always a pain. So I knew about it, but I didn't know about it. Third, I noticed there was some exiting problems, probably about a half a dozen exiting issues. I don't remember what they were to this day, but I just remember there were some exiting challenges. So we get all done with the drawings. He closes them. He said, what do you think? And I said, it's great. It's creative. He could tell I was hesitating. So he said to me, but what? So kind of embarrassingly, I said, well, and I rehearsed with him what we just talked about. And I said, what are you going to do about it? What do you think he said? You're all right. Basically, he said, don't worry about it, Dave, because I'm going to turn it into plan check. They're going to make a list of corrections, and I'm going to fix them all. Oh, my gosh. I can see it with a minor exiting issue, right? But if you're going to have to go in and redesign for wider corridors, right, it's going to ripple affect the entire design. I'm thinking, oh my gosh, there's something wrong here. I don't know what's wrong for sure, but it doesn't feel right. You know what my first thought was? Oh, why did I sign up for this? This is not the career I want, right? And not only that, I'm bringing into this person's office, I'm bringing in something that no one likes. Does anybody here like fire doors? No. The only person I know that I know well that likes fire doors is my wife. That's it. Pays the bills, right? So what drives the need for the fire door? I was confused, honestly. I was very concerned, so I canceled all my appointments the next day. I don't know how many of you have heard, or there might be an alumni here from Cal Poly University, either Pomona or San Luis Obispo in California. So I grew up on 2,000 acres kicking cows just close to Cal Poly. So I knew where it was. So I canceled all my appointments the next day. I drove to the university. I was too young and stupid to know. I'm still stupid, I'm just old, right? But I was too young and stupid to know you had to have an appointment to talk to the Dean of Architecture. So I walked in. His gatekeeper was keeping me from him. He happened to walk by and he said, "Son, don't you know you need an appointment to see me?" I said, "Yeah, I know now." Anyway, he said, "I'll give you 5 minutes." He was very kind. "I'll give you 5 minutes right now. What's the problem?" I said, "In order to graduate with a degree in architecture from this university, how many hours in the curriculum are relegated to the model building code?" What do you think he said? "Oh, you people are just, you're negative." Yeah. He asked me, he said, "Do you want to know the truth?" "Oh, no, I don't care about the, no." I said, "Of course I want to know the truth." He said, 1/4 semester hour watered down. That's how he described it. What's that? 0. I left that university that day. Now my head was really spinning. What did I get myself into? And I realized this: you don't care about the manufacturer. Don't lie to me. I know you don't. Yeah, you really, as long as we bring freebies and goodies and, you know, what you care about is getting a problem solved, right? Doesn't matter who makes a product. And sometimes, for some of you, I probably shouldn't say it in this open crowd, you don't even care if it works after CO. Yeah. Yeah, did you hear that? That's the contractor's fault. That's right. Yeah. Well, you can tell we're not going to spend the time in the presentation today. This is what the code says. We're not going to do that, are we? We're going to talk about it. We're going to talk about it in ways you probably are not used to. So I left there that day with realizing this fact. What is it that drives the need for a fire door? There's no curb appeal. It's not a design issue. Except the design issue is we need open, spacious designs. We don't want to close things down and inhibit spaces and the functionality of what we're designing with sheetrock walls and swing doors, do we? That's not the idea. But what drives it? What drives it is the building code. That's what drives it. So I immediately joined a local ICBO chapter at the time. A friend and I sponsored and started a chapter a year later. Concurrent with all that, I joined the LA Basin, Los Angeles Basin chapter, became a very viable member, serving on the committees. Next thing you know, I'm serving on regional committees. In 1995, I was asked to join a committee where we began to put together this infamous International Building Code. That's when we started working on it, putting it all together. I think I've missed one code development hearing in 37 years. That's nothing to brag about, by the way. Nothing to brag about. In fact, I'm not going to go there because that's not what this seminar is about. But by way of introduction, just so you know, the building code is all about politics, emotion, and money. Period. I've lived it for 37 years. I know what I'm talking about. There's very little life safety left in it. Now, if there was someone from ICC in the room, and there might be, they're going to go, "Dave, stop it." But the truth is that it's a very difficult process. It's a very laborious process. Code consultants are more lobbyists than code consultants. That's just the way it works. So I spent the last 37 years in all of that, and right after I left that appointment that day in 1988, I never again gave a product presentation in a 1-hour box lunch. It was chapter 10 or chapter 7 or a combination of both out of the model building codes, and away we went trying to understand that. Okay, in your hand is a booklet. The net result of all of that over the years and I don't know what edition this is, 13th or 14th, whatever it is. This document is the net result of what I learned from all of that. And what you'll see, we're going to spend our time, obviously, as we start the clock on the Florida Building Code with this presentation. It was difficult at first to get the approval process because I reference the IBC and we talk about where this stuff comes from that you deal with in the Florida Building Code. It didn't come from Florida. Florida just simply has adopted the IBC, made their own amendments, yada, yada, and that's what you have. And so in some cases today, we're going to have to go back to the root cause of some of these challenges and problems that you find in the building code, okay? And what we're going to do is we're going to take, over the next hour and a half, we're going to take essentially some of these basics that typically, I'm ICC certified as an instructor, and I typically spend anywhere from 5 to 8 hour days doing seminars for building officials, fire officials, and design teams and engineers. We're taking some of those pieces out of that and whittling that down to the next hour and a half. Okay? Now, if you turn to page 108 in that document, what you're going to find is an appendix. And in that appendix, you're going to find the 5 walls of the IBC. And as you take a look at the 5 walls of the IBC, you know, I think the first concern is what was wrong with what we had, right? Why do we have to name these walls? So the title of the presentation, as you know, we have to roll through. This is the political stuff. See what I'm telling you? We got to roll through all this stuff initially. I'm not going to bore you with, I'm not going to tell you what I'm going to talk about and then tell you again what I talked about. That you're supposed to do that. It doesn't make any sense to me, does it you? All right, so what we're going to do is we're going to explore the 5 walls of the Florida Building Code. And those 5 walls essentially are a redo of what we used to have in the old legacy codes. So in other words, now instead of having just one wall, in fact, let's talk about that. If you were to take 3.5-inch stud and throw a layer of 5/8 on each side, for all intents and purposes, what's that rated? All right, if we throw 2 layers on each side, what's it rated? If we throw 3 layers on each side, what's it rated? 3 hours, yeah. A lot of people go stupid. I'd go CMU at that point. What are you doing that for? Yeah, well, you probably would. Well, but at the end of the day, how did we classify that wall in the old legacy codes? By its what? That's right, by its hour rating. That's how we always looked at it. At my age, you can't drink a whole cup during a presentation. You know why, right? Just a sip at a time and stay away from it. So what happens? What happens then is we take a look at the old description of the wall and we learn that it's basically categorized by its hour rating. Now all of a sudden, excuse me, we have a fire wall, a fire barrier wall, a fire partition wall, and a smoke barrier and a smoke partition wall, right? And it's like, what's this about? You know, we did this back, this was rolled out, you might remember, in the 2000 IBC. Everywhere I go, there's still some challenges and problems with understanding what are the 5 walls, where do they go, and why do they go there? And by the way, if we're going to open them up, how do we do that, and how do we deal with it? How do we comply? So we're going to limit our discussion to those areas this morning as we talk about those 5 walls. Let me suggest something to you. We all struggled with this whole new concept back in the late 90s as we put it all together. We all struggled with this fact of 5 walls. It's like, really? And then eventually we embraced it because it really is a good thing. And let me tell you why. When you look at these 5 walls, you want to categorize them based upon their use and their application, not their fire rating. That'll come. That's a necessity. You're going to have to lean back on that fire rating, and with the smoke partition and the smoke barrier wall, you're going to have to add a UL 1784S label into the mix, so to speak, as well. But at the end of the day, you have to look at these walls based upon their use. Now remember, they never overlap either. So in other words, each wall has a responsibility and a job to do in that structure under what we call the law of passive redundancy. And so with that in mind, it's much easier for us to realize, hey, wait a minute, there's a wall, it's named, and it's a niche for what I have to do here. Now, I would suggest to you that probably 85 to 95% of any rated wall that you'll ever use in a structure is going to fall under the category of number 2 up there. It's going to be a fire barrier wall. We know that firewall walls have only one purpose. What is that purpose? Yeah. The building code wants you to go across the street and build another building. Right? They don't want you to exceed anything in chapter 5. It's that simple, right? So understand that the firewall concept is a give me to you. It's not mandatory. Nowhere in the code are you going to find except a little footnote B on one table in 602. Where you have separation of structures. You're going to find a little footnote there that sends you to 706 that you're going to have to put that in as a firewall. I have yet to see anybody enforce that. In other words, when you talk about an exterior wall that is less than 5 feet away from another building, we all get that. You got to rate it. You got to do all the opening protectives. Everything has to be handled. But everybody forgets about the fact that that footnote sends you to 706 to design that wall. What's 706? It's an independent, structurally independent firewall. Do you want to make all your exterior walls according to that recipe? No. So we're not going to go there. We could talk about that for the rest of the time, couldn't we? We're not going to deal with that right now. But that's the only place I know of anywhere in the code where the firewall has any kind of mandate or direction that you have to use it. Now, why is it a give me? It's because once you exceed that area allowance, then the code says, okay, if you'll put in this structurally independent firewall, now you can exceed that allowance and you can consider multiple buildings, minimum of 2, under one roof. And again, that's a topic that in the hearings, year in and year out, cycle in, cycle out, we discuss that over and over and over again. It's quite the topic. We could spend the rest of the time just discussing the use of fire. We're not gonna bore you with that. Okay, but that's a hot topic. It's really a tough issue sometimes. Okay, so remember, the firewall's a give me. If you use the firewall, it's a designer's choice. Now, once you make that choice, you bought the farm, didn't you? Yeah, now you got to comply with everything that's going on in 706 and all the references that go with it, all the way to the point of double wall, firewall, and that whole concept. And then all of a sudden you'll find that we finally adopted NFPA. You might want to jot this down under the firewall section on 108. We finally adopted into the code NFPA 221. NFPA 221 is the recipe to bake the firewall cake. That's where you go to get that instruction. Now that I've given you that, let me just tongue-in-cheek tell you, and it's more than tongue-in-cheek, NFPA 221 lacks credibility and it doesn't take the water to the end of the road. I've testified against NFPA 221 several times in the hearings. It is not a great standard, but at least it's a starting point or a starting place. Now, one last point while we're on this screen. As you look at those 5 walls, we need to understand that those 5 walls, except for the last one, the smoke partition wall is a crock wall. Should have never gotten a code. It was not there in the 2000 IBC. There were only 4. And then, I just don't have time to tell you the story, but eventually that got into the code. And so it carries no fire rating. So the first 4 walls carry a fire rating. They're all rated the same when it comes to test criteria. That's ASTM E119, the wall test. UL calls it UL 263. That wall test is what they use because it's going to mitigate the transfer of heat. And so that is the purpose for that test criteria. All 4 of those walls have to pass that test criteria. Given there might be varying ratings such as 1 hour, 2 hour, 3 hour, or 4 hour, but nonetheless it's the same criteria. Now, however, the application of the wall in the structure lessens as you descend this list. Let me say it again. The application, meaning the fire application and its job that it has to do in the rule of passive redundancy, lessens as you descend the list. That's a clue for us to understand. That is why we need to know that each wall has its own use and its own purpose. Therefore, the best way to get our head around the use of these walls is to understand their use and purpose. Are you with me so far? Okay, let's move on, and let's take a look at a couple of fundamental issues that are extremely critical to understand. And that is the difference between fire resistance and fire protection ratings. Now, Stuart Tom, does that ring a bell to anybody? It probably wouldn't, because that's not your arena. Stuart Tom, by the way, in October at the ICC annual meeting will be put in as the president of ICC. He's a great friend. He and I go way back in the Los Angeles Basin chapter. He used to be the one that was our educator. He taught us all the time. We all loved it. He would always start the seminar this way. Code seminar. He would say, you know, we can all memorize the code. It's not that big a deal. I remember in those days when I was just a punk with brown hair, and I'd say, you're up in the night, Stuart, right? But he'd explain it. He'd say, with the exception of chapter 7. Chapter 7 is the chapter that's all messed up. It still is. It always is. In fact, you know what chapter 4 is, right? Chapter 4 is the gotcha chapter. You know why? Because when we can't figure out where else to put it, we throw it in chapter 4. It's true. And if you're in the middle of a design and you're working with a code consulting firm or not, either or, everybody knows you better consult chapter 4 before you turn those into final CDs and send them to plan check, right? Something's going to bite you in the rear end out of chapter 4. It always does. That's why chapter 4 is designed this way. You walk into a hospital, we'll go back and use that because it's an easy example, right? We know that in chapter 10 of the Florida Building Code, we understand the rules of egress, we understand door assemblies, we understand self-closing, we get all of that. So if you're going to have any kind of a door on any kind of rated corridor, even if it's just smoke rated, you got to have self-closing automatic systems, right? Every time. Well, what if you're in a hospital? What if there's a crash cart, there's an emergency, and that door keeps closing and creating a problem, and we lose a life because of it? So what we do is we go back and say, wow, there's got to be some things that's got to be different here. So what we do is we go to chapter 4, and this particular one is in 407. We go into 407 and we create a bunch of rules that step aside from what's in chapter 10. That's what chapter 4 is all about. You want to learn about storm shelters, hurricane systems, all of that, the ICC 500 standard, you go to section 423 in chapter 4. So in other words, what we're doing is chapter 4 is that catch-all chapter. Chapter 7 is the catch-all chapter in the code for anything to do with fire resistance. You with me? Therefore, you can go into chapter 7, you can read almost the exact same descriptive adjective language for a door that you see for a wall, and vice versa. You've run into that, haven't you? It gets very confusing. It gets very challenging. We can't fix that. You know why we can't fix it? Is because we use chapter 7 as the catch-all place to throw anything to do with fire resistance. So, you know what? We just can't mess in our own nest. Yeah, so it's a mess, all right? So let's try to understand it. I think it's understandable. I think we can go through it. And that's what we want to talk about. So on the screen, you'll see that it says in 202, which as you know is the definitions portion of the code, what you'll see there, and I'm gonna read that, read it with me, okay? The fire resistance. If we had a real small group, I'd just have one of you read it, but we got to keep moving. So what is a fire resistance rating? Remember, we're doing this to try to understand the difference between a fire resistance rating and a fire protective rating. Got it? Okay, so a fire resistance rating, a period of time, a building element, component, or assembly. Wow, we nail that down, don't we? Maintains the ability to confine a fire, continues to perform a structural function, BS, or both, as determined by the tests or the methods based on tests prescribed in 703. Now, let me stop here and give you a little clue about the code. You'll never find one answer, let me rephrase that. You'll never find the final answer to any code question in one place. Don't you hate that? Okay, here's how to solve that problem. Now, this takes some work, so hang on. You can do this electronically. You can do it with an electronic notepad, or you can do it like some of us old guys do with a Columar pad or a yellow pad. But when you're searching something, go to your first spot that you're searching. Write down the code reference number, and then write down in your own words what you think that says. And then follow the reference to where it sends you, because it's going to send you through the forest, up over the hill, and around the tree, right? That's what it's going to do, right? So every time you come across the next reference, do the same thing to where you have in this notepad, you have this list of everything that you've just studied. You got it? Now, some of you have done this just because you had to, right? Out of desperation. Learn to do that all the time. It's the only way you're going to get your head around it, and I don't have time to explain it to you, but it's because of the code development process. The code is an amalgamated document. We just keep adding to it. We don't go in and wipe all this out and then put in something new. What we have to do is put in something new that feathers in and works with what was already there, because it plays on top of that. That's the way the code is written. So you have to go through that same process of how it got that way when you're doing your study. So just write that stuff down and go through it, and then you'll be able to see a trend. You'll be able to start seeing identifiers. Oh, if I do that, I get that, and that. And then it'll start, believe it or not, it'll make sense. No, it never will. Ann Von Weller, the second president of ICC, great friend. We worked together for several years. Ann Von Weller, one time, right after we published the 2000 IBC, the concrete industry got totally out of whack with it. They were just totally upset. They said, you've increased multi-story structures 200%. You've increased single-story structures 300%. With no additional safety mechanisms, and the fire departments were even worse about it. I mean, it just got to be a big problem. I was appointed to a committee to go into Chapter 5. At that time, it was one table, remember, 503? I was assigned to go in with this committee and start tweaking the values on 503. We couldn't do it. It wasn't possible. The ripple effect was ridiculous. So we ended up just tweaking 504 and 506, some of the height and area and some of those allowances. That's all we could tweak, right? So Ann and I were at the conclusion of a meeting one time, and after the meeting out in the breezeway, I said, Ann, she's just a few years older than me, so I always teased her and called her Mom. I said, Mom. She goes, don't call me that. I said, Mom, what happened? She goes, what are you talking about? So I reiterated to her what I just described. She knew it. And I said, what happened? She goes, why are you blaming me? I go, it's on your watch. She goes, I wasn't on the committees. I'm not the one that did that. Finally, she stopped me. And she put her index finger up on my forehead. You know what? We have to demo this, okay? So you okay? Okay.
You picked the right guy.
Is this the right guy? All right. So we're going to find out if he's had this done. I call it the mom thing. You with me?
You want me to stand now too?
No, stay right there. Well, you got a lot of ribbons on there. Does that mean something? That's pretty cool.
Just means I'm dumb too.
Wow. Past president, member. I'm going to get in trouble. So anyway, what happened is she walks up to me, puts that finger right there, that index finger, and called me by my full name. You know you're in trouble then, don't you? And here's what she said, speaking of the code. She said, David, don't you ever forget this. The finger of God did not write this crap. Isn't that good? I told you it wouldn't be boring, right? Now, she's the president of ICC, and she's telling me that's how she feels about the code. One of the great members, I won't name his name, but he said to me one day, David, these were not written on Mount Sinai. The code was not written there. The finger of God did not write this code, okay? You have to understand that. You have to accept that and realize it's an amalgamation of ideas, emotions, and money, and some people's energy. I probably better use the steps, huh? And all of this to put this code together. Wow. We're not going to get through all this. I'm telling you too many stories. All right. Now, so when we talk about a fire resistance rating then, what we have to do is we have to look at the difference between that and a fire protection rating. And Chapter 7 doesn't help us very well there. We have to understand the fundamentals behind it. If we can understand that, we can get there. So up on the screen, what you see is we've got a wall, and we just put a fire in front of the wall. And we have three designations there that I already mentioned. UL 263, NFPA 251, all of those are the result of the test criteria that was originally written in ASTME 119. We call it the 119 wall test. You with me? What that means is we're going to stop the transfer of heat through the wall at 250 degrees Fahrenheit. That's the purpose for either 1 hour, 2, 3, or 4 hours. That's a fire resistance rating. Even though we see the term used interchangeably in Chapter 7, it's not supposed to be that way. The fire resistance rating is relegated to the ASTME 119 criteria, and I'll say it again, which stops the transfer of heat at 250 degrees Fahrenheit. Now, what does that mean for you? When you throw a wall on the drawings that's rated, you know what? You're stuck. Building and fire officials use that as a benchmark. That's a beginning point. It's fixed. It's not going to move. It's going to do its job. The interesting part about that fire resistance rating is that essentially the fire has to go to it. It's passive. That's what we call passive systems. So if a fire was to break out in the middle of this room and the systems kick in, we're going to see two things. One's very subtle. The first one we're going to see is hit the wrong button. We're going to see the sprinklers deploy, right? That's the redundancy. That's the active system. The passive system, which has always been there, is going to be that fixed wall that is going to stop that from transferring. But the fire has to go to it. It can't get up. It's silly to even ponder it. It can't get up and go to the fire and confine it. It has to depend on the redundancy. Hence, in the code, especially in what you have in the Florida Building Code as a result of the IBC, is you're going to see a lot of dependency upon active systems, right? You sprinkle a building, you don't have to rate the corridors anymore. You sprinkle the building, you get allowances, you get added area, all of that. Sprinklers carry a tremendous amount of weight. Now, categorically, let me just suggest to you, when we can't solve a problem at the code development hearings, and by the way, those hearings, other than plumbing, mechanical, and all of that, are divided into 3 categories of code changes. One is fire safety, the other is general, and you know what fire safety is going to be, largely Chapter 7 and anything related. General is going to be all the other chapters except Chapter 10, and then egress, Chapter 10. Believe it or not, in a 7-day period, we listened to approximately 210 to 260 code changes in each of those 3 categories. And we got to get that thing on the table and off the table in a matter of a couple of minutes in order to get through everything. If not, then we do what we always do, and that is we start at 8 in the morning, and then we end up going till midnight, 1 o'clock in the morning, and then we're back at 8 o'clock the next morning. Why? Because we got to hear all the changes and vote on all of them. So what happens then when we talk about these code changes? What if there's no empirical data? What if the code change on the table is not well backed up, which is 99% of the time? Until you get into CLT. I don't even want to talk about that. But what happens is we got to make a decision. So we affectionately call it playing the sprinkler card. You're reading into that, aren't you? Whatever's going through your head is right. Okay? In other words, what happens is if we don't know the answer, we just simply say, oh, is the building sprinklered? Yeah, okay, well then let's do this. I'm serious as a heart attack. It's ridiculous. It's crazy. I wish we had the time. I'm going to walk you through one, actually, that's a big faux pas, but this stuff happens all the time. And you end up with a finished document that sometimes just makes no sense. That's why. That's why. All right? Wow. I'm going to get in big trouble, aren't I? All right. So that's what we call passive redundancy. Now let's move on to what we would call an opening protective rating. An opening protective rating is relegated to door assemblies or opening protectives, just like it implies. So let's read this together. What's a fire protection rating in 202? The period of time that an opening protective will maintain the ability to confine a fire as determined by tests specified in 716, which is, as you know, the opening protective section. Ratings are stated in hours or minutes. Now, do you see anything in there about the transfer of heat? Nope. There's nothing about the transfer of heat. In fact, when you put an opening in a rated wall, in this case, by the way, that is a fire barrier wall because it's an occupancy separation, obviously. When you put an opening protective in that particular location, then it's not equal to the wall. By the way, if you're in Australia, it has to be. The door has to be equal to the wall. But in our codes, that door does not have to be equal to the wall. It can transfer heat all day long with no problem at all. Now, we're going to come back to this opening protective slide. Let's go directly to that test criteria. So in section 716, we find test criteria for the opening protective. How does that work? What does it mean? I think this quick explanation will help you a lot in understanding the difference between the fire resistance rating of the wall and the fire protection rating of the door assembly. You with me? Okay, so that is the furnace configuration. This is all UL mandated. Most of us do most of our testing at Intertech, some at UL. The only reason is because UL has gotten very, very, how can I say it, very expensive and time-taking. They kind of run on their name, so to speak, when it comes to actual test furnaces. So most of us all use Intertech, the same criteria, same test, everything's the same. It's just that it's a little cleaner and faster, and there's more laboratories available to us. So don't get confused by that. You can have a UL listing that's bona fide and certified. It doesn't have to come from a UL test lab. UL puts out the test criteria for everybody. Now, that's the furnace. You put a specimen or a door assembly in the furnace. And then you turn the furnace on and crank it up to 1800 degrees plus or minus Fahrenheit, because you want that heat against that door assembly. Now, fire, as you know from the old Backdraft movie, fire is a monster. It eats oxygen. It'll do whatever it has to do to get oxygen. So one of the vulnerable parts of the door assembly is at the sill. So what you're going to see is the fire creating this vacuum as it essentially in the vernacular just sucks that makeup air into itself in order to continue to burn and survive. And so that creates a negative pressure in the furnace. Now, look at the top right of the furnace configuration. You'll notice that it's wide open. So what happens is all that combustion pressure goes right out the top of the furnace. So we have no combustion pressure that's pushing against the test assembly. Wow. It's been this way, by the way, since 1902, when UL first began and started this, put this criteria together. And by the way, UL didn't come up with all this criteria. In the year 1890, that's not a code section, just right after I was born, what happened was there was a lot of fires and problems in the U.S. And so the only people that cared about it were who? We'd like to think that. Yeah, they did care about it, and they care about it today. And we could reverentially take a moment and thank them. Don't misread this. The only people that cared enough to do anything about it were the insurance companies, right? My dad said when I was a kid, if you don't understand something, son, follow the money, you'll figure it out. Best advice he ever gave me other than be nice to mom. And so when you follow the money, the insurance companies and fatalities were losing big time. They said, we've had enough. So in 1896, 9 insurance companies got together and formed this whole new organization in order to write criteria, test criteria for particularly these passive systems. You know the name of that organization? The National Fire Protection Association. NFPA is not the righteous organization that you might think it is under the umbrella of the State Fire Department. NFPA is owned by 9 insurance companies today. They still own them. And every time something goes south, they call up their company and say, write a new standard, and they do. That's where NFPA 101 came from. They started having fatalities in non-ambulatory facilities, and so they said, hey, you got to stiffen the exiting requirements. The building code doesn't cover it well enough. All right. So about 1913, just a few years prior to the first uniform building code in the U.S., which was printed in 1921, they started working on it. Finally, they released a document that is a standard. The name of that standard, the nickname for it, is the exiting code. Why? NFPA 101 was written to stiffen the exiting requirements to protect non-ambulatory folks in those buildings so the insurance company's not holding the bag. Politically speaking, in the 70s and 80s, we saw NFPA, we saw the feds get their teeth in it. Once they did that, it became a document that has become kind of a nightmare. And I'm playing that down, aren't I? That's where it all came from, okay? So when we talk about NFPA, UL10B is based on NFPA 252. That's who wrote the standard. UL in 1902 began when a free enterprising individual said, hey, NFPA wrote all these test standards, but they don't provide a furnace to test. Why don't we do that? Okay, so UL organized themselves, became a viable business, and they reached across the aisle and said, we're not going to rewrite all this stuff. We're just going to give it our own name. So when you go to section 716 and it says NFPA 252/UL10B, have you noticed that before? You're going, what in the heck does that? You don't even care, do you? No. It's like, what the heck is that? Believe me, all it is both own the intellectual property and they want the credit for it. It's the only reason it's in there that way, okay? So that's where UL10B comes from. So what happens then as that furnace heats up, what we are testing is not heat transfer. We're testing flame through and flash through. That's all we care about on an opening protective. We don't care about that it radiates 100% heat. It can be 1800 degrees on the cold side. It doesn't matter, as long as you don't get flame through and flash through. So what about this issue of all of the combustion pressure going right out the top of the furnace? What do we do about that? In the early days, here's what UL did. You put the test specimen in the furnace. You don't light it up. You don't burn it. But you hang ropes from the purlins in the lab. You tie sandbags on the bottom, and you just beat the heck out of this door with the sandbags. Pretty scientific, huh? And then you crank up the furnace. And if you get flame through or flash through, then you flunk the integrity test on the door. Well, believe it or not, there were two people at lunch one day. One guy from the UL lab, another guy from a lab up the street that was testing smoke windows for smoke leakage. Two different labs. They weren't burning the windows, they were just testing them for smoke. So they got chit-chatting about it. The guy at the smoke leakage facility started laughing at the UL guy and says, you're kidding me, you beat that with sandbags? Oh yeah, it's a lot of fun. And he said, well, what do you do? He said, what we do is we take that multi-pane window, we put it in a test wall, and then we take water hose, pressurized water, we zigzag that water back and forth, and if any water leaks through significantly, we know smoke will leak through. The guy goes, oh my gosh, the guy at UL. He goes back, guess what? That was the birth of what test? The hose stream. That's where the hose stream came from. Now, they went to ASTM and had them write the criteria. But the concept was that somehow we have to test the integrity of the door. Now, the challenge with the hose stream is that when they put it all together, they don't introduce the hose stream until after the burn. Who cares at that point, right? Well, it became a challenge. And this is what the hose stream looks like. We don't need to spend any real time on it. But the purpose of it is to test the integrity of the opening. Now, why do I bring that to your attention? Often we hear that we have to keep the hose stream. We have to do it because when these sprinklers deploy, that water's going to hit these doors. And what's it going to do? Does that have anything to do with what we just talked about? Not at all. But that's always the rationale for the hose stream. But if you understand the hose stream, it is a structural integrity test. And you can see in these assemblies, if you look at the floor, you can see there's just a ton of water. And obviously what we're looking for is, can you stop that water? If you can, not all of it, but if you can stop the majority of that water after the assembly burns, then you're going to be able to react as an integrous assembly during a fire. Okay? Now, here's what's interesting. And the Florida Building Code picked this up as well. No amendment was made. Okay? UL10B is for all doors other than swing doors. UL10C is a positive pressure test for swing doors. UL10A is the same as 10B, only it's relegated to big slab doors that we saw back at the turn of the century all the time. Once in a while you see them now. So 10A, 10B, and 10C, all designed in order to pass an integrity test. Every one of those criteria require a hose stream to get any kind of fire label on a door. Now let me say it again. Every one of those require a hose stream, even if you want to get a 10-minute label on a door. The only place in the world that that's amended is in the United States. I teach the code all over the world, by the way. And let me tell you, China, Australia, the Middle East, all those areas, they do not do this. We do it here, and it's on the screen. Take a look at what I'm talking about. When you jump into 716.5.3 in the Florida Building Code, it'll tell you door assemblies that are located essentially in corridors and smoke barriers. What are those two walls? Fire partition walls and smoke barrier walls. When you locate doors in those two assemblies, fire door assemblies required to have a minimum fire protection rating of 20 minutes where located in corridor walls or smoke barrier walls shall be tested in accordance with 252 or 10C without hose stream. Wow. So what we're saying is that our code, our accepted model building code says, forget about what that says in 10A, 10B, and 10C. You can get a fire label if you pass the burn and flunk the hose. And the fire label maxes out at what? How many minutes? 20 minutes. So you can get a 20-minute label on a door. And this is critical. We'll talk about it later. But I'm planting these seeds for you to have it in the back of your mind so you understand it. By the way, New York City amended that out. Any fire door in New York City that's got a 20-minute label has to pass a hose stream. Interesting. So you see different amendments in different areas of the country, okay? Now, temperature rise. Where would you use a temperature rise assembly? Who said that? Raise your hand, would you? Thank you. Very astute. He's exactly correct. Until the 97 Uniform Building Code, which carried over eventually into the 2000 IBC. Here's what happened. It was very interesting, and this will help you understand the hearings. Someone came to the hearings and said, hey, we think, this is 1995 for the 97 UBC. I was there. It's a very interesting dynamic. We all thought this code change will never pass. What they wanted to do was eliminate temperature rise doors. Let's go ahead and build the slide so you can see the information that goes with it here. A temperature rise door means that you're going to insulate that door enough that you're not going to exceed in the heat transfer 450 degrees. There's also a 650 degree temperature rise. Yeah. And the reason I'm hesitating is because it's never really used. The 450 is what we enforce 99% of the time in the code. So what happens is that you're going to stop the transfer of heat at 450. So this person came to the code hearings with a code change and said, we think it's an overkill. We don't need a temperature rise door. All in the interest of what? Saving money in the construction of the building. Heck with fire life safety, that doesn't matter. Honestly, I mean, I'm overstating that, but I'm not. Follow the money is where you find the answers to these crazy questions. So anyway, he comes in and says, we're going to get rid of that. We think it's an overkill. We really don't need it. We're going, this code change will never pass. So he presented his argument. Here was his argument. He said, how many in the room want to touch a door when you're exiting a required exit stair? Now we call it what? An interior exit stairway. Or you can be old and call it a vertical exit enclosure. Isn't that fun, keeping up with all that crap? By the way, those people just do that, just have an editorial change in the code and have their name in lights. There's no meaning to it, right? So you're exiting an interior exit stairway. Does anybody here want to push on a door that's 440 degrees? Do you want to push on a door that's 140 degrees? No, he made that point. We're all going, wow, good point. Yeah, that's cool. Now where's he going to go, right? And so the next little concept that he presented to us was this. He said, if you have a 4 to 7 story B occupancy, medium size, right? Floor plates are not huge, but they're not small, kind of a medium size office building. He said, how long will it take to evacuate the building? What do you think? Any guesses? 20 minutes, good. 30 minutes, good. He had fire departments stand up and testify that in those lower story buildings like that, they figure 1 minute per floor. Yeah, until you hit like 8, 9, 10. Once you start hitting higher than that, it's going to be a little more. So he said 4 to 7 minutes, you're going to have everybody out of that 7-story office building. Except some of us that are stubborn, right? Don't want to leave. And so he says because of that, he said, how long is it going to take that door assembly in that stairwell to heat up? What do you think? Well, first of all, it's at the core and shell. Very seldom do we see fires begin at that core and shell in a stairway, right? And even if they did, how long would it take that fire to heat up that door to exceed enough and radiate enough heat to hurt somebody that's leaving? What do you think? It's going to take a long, long time. In other words, his point is everybody's going to be out of the building and long gone before that ever happens. So he said it's an overkill. Now here's what happened on the floor. The discussion ensued. The proponent of the code change could tell that that's the end of the empirical data. And none of that's empirical data, right? All that's just, well, this is what we played with, this is what we figured out, and this is what we think, and this is why. And we got to get this code change off the table, right? We got to get on to the next code change. So somebody said, let's do a friendly amendment. One of his team members did a friendly amendment. They played the sprinkler card. So they submitted to the committee on the floor, well, what if we sprinkler the building? Can we then get rid of the temperature rise? Yeah, that's a good idea. I was there. That's what happened. And so in that section, in 716, you'll notice that the charging language says what you're going to have to do is put a temperature rise door in. Then there's an exception, and the exception says in a 903.311, in a sprinklered building, you don't have to. And you know what? The vote passed, and we're done. And you have that today in your code, very scientifically proven and thought out. You're not going to hear that from anybody else. But after 37 years in the code hearings, I'll tell you the truth. That's how it works, seriously. Now, if it was in defense, if it was a huge problem, obviously that's not going to happen. But everybody bought off on the sprinkler card. Interesting? That's how that stuff gets written, okay? Now, can you test a door assembly to a wall test? You can. Everything is exactly the same as we talked about. Now, finally, what happened in 1995 in that same code hearing that I described to you, there was another code change that came. Fire protection engineers are tired of the hose stream. They think that it's antiquated because we introduce it after the door burns. And they make a great point. So they came to the table with a code change. And the code change was, what we're going to do is we're going to get rid of the hose stream. Now, let me back that up. Watch the upper right of the screen for a minute, okay? Watch what happens to the configuration of the furnace. Close the damper, right? So by closing that damper, what you're going to do now is you're going to force all the combustion pressure back against that door assembly. And when you force all that combustion pressure back against that door assembly, now you have a true test of what that door is going to do during a fire, instead of waiting till after the burn and hitting it with a hose. Now remember, the purpose of the hose is that you can touch every square inch of that door. It's not just about the water, it's about what the water's doing to the door when it touches every square inch. That's why the water's effective. Well, it's more effective to come in, and the optimum location was 40 inches above the sill. And that's called the neutral plane, where the negative and positive pressure meet. And if you can introduce that, then you're going to have enough pressure against that door. We don't need the hose stream anymore. You with me so far? All right, this gets pretty serious. Here's what happened. The proponent of the code change could tell that it wasn't going well. Not everybody on the rostrum that was going to vote, the 13 members of the committee, didn't really understand all this very well. They never do. It's a real challenge. That's why you have a hearing. That's why people testify. That's what's going on, is educating everybody in the room, particularly those who are going to vote on the rostrum. So they said, what we're going to have to do is figure out how we're going to deal with this. So it was a two-part code change. The first part was, Part A, is, wow, this is a great test. Yes, we totally accept this test, the positive pressure test. And by the way, at the time, it had no name. So ignore that 10C on the screen. It had no name, okay? And so they said, yeah, we love the test. You're right. That's what we got to do. Part B of the code change was, okay, if you like the test, then let's vote out the hose stream. No more hose stream. Part B failed that day. Part B failed. Wow, where's this going, right? So here's the way to help you understand the discussion that took place to cause it to fail. So I want you to think for a moment, every one of you, think for a moment about your garage or your storage shed out back. You got it? Are you looking at it? Is it in your head? Okay, why do you keep all that crap? Don't anybody pull the spouse card. Don't anybody do that. That's not the rule. Tell me, just shout out, why do you keep that stuff? Might need it someday. Why else? Has it got sentimental value? Say that louder. Yeah, all of that, right? That was exactly what was discussed on the floor that day. I'm serious. Everybody said, we've always had the hose stream, we can't get rid of it. Nobody came up with empirical data. Nobody came up with test results. Nobody came up with anything. They just all said, I was sitting there. Yeah, we've always done it. We can't not do it. Oh my gosh. So it failed. When that failed, guess what happened? They took that positive pressure criteria and named it. That's when UL 10C came about. It wasn't in existence till then. Eventually that rolled into a new UL criteria called 10C, positive pressure testing, relegated to positive latching swing doors, which means that we got 10A for slab doors, we got 10B for all other doors, and now we got a positive pressure test, 10C for positive latching swing doors. And guess what? If you want greater than a 20-minute label on a positive latching swing door, you have to do what? Pass the hose. Are you starting to get the picture of code change and code development? Yeah, nothing changed. I'm telling you, it's just absolutely crazy. So we move into all that. Now let me share something with you, and I don't want anyone to be offended about this. So, nowadays you don't know what to say or what not to say anymore, do you? So let me just share something with you, okay? How many of you are familiar, by raise of hand, of the fire and smoke rated fabrics that have come over across the pond from Europe? You know what I'm talking about? Okay, those fire and smoke rated fabrics, and we manufacture, we're actually the largest manufacturer of those fabrics in the United States. Most of it all comes from everywhere else. Can I just tell you that at that time that discussion took place, the fire and smoke rated fabrics were not on anybody's radar screen. This is 1995. The fabrics didn't come over here and begin to come over here until about 2007. And it really became more obvious in 2008, but it became a market item in 2014. So they weren't here. Nobody even knew about them. They weren't a gleam in anybody's eye even. In that hearing. Now, here's the tipping point. The fire and smoke rated fabrics will not take the hose stream. They fail the hose stream every time. The maximum rating you can get on the fabric is 20 minute, and only because of the give me in the U.S. codes. Are you with me? What I don't want you to get offended about is I'm going to suggest to you that day in 1995, when we were sitting there, none of us could figure out why the second part of the code change was voted no. We were upset about it. I was one of them. We thought this is great. A positive pressure test to replace the hose stream, there's nothing better. But it failed, and we were all miffed and mad about it as we basically stomped out of the hearings at the end of the week. None of us had any idea somebody somewhere was looking over us, because can you imagine the fabrics now that won't pass a hose stream if a hose stream was not required anymore? Oh my gosh. Now the hose stream is still here, and if you want to get greater than a 20-minute rating, you better have an assembly in the furnace that will withstand the pressures during a fire. And without the hose stream test on the fabrics, we would never be able to know that. It's amazing. It all works out. Okay? And we're not here to talk about the fabrics today, so let's just keep moving. Firewalls. Just by show of hand, how many of you in the last 12 months have designed a firewall? Wow, that's good. Okay. Let me give you a quick little snippet that's not in on the agenda, but I think it'll be very helpful to you. Double wall firewall. When you go to NFPA 221, I'm going to go real fast. When you go to NFPA 221, it tells you that in a double wall firewall, you got to have 2 door assemblies, 2 opening protectives, 1 in each wall. You don't need to. That shouldn't be in that standard. It's one of those ridiculous things that nobody understood when they put it together. Why? Because the double wall firewall is the architectural design team answer to what the code does not address in the Florida Building Code. In other words, when you talk about a firewall wall, there's no recipe to bake that cake. You won't find the structural requirements, will you? One of the biggest challenges when you hand off the firewall to the structural engineer is they'll get back to you and say, hey, where's the recipe to bake this cake? You know, how do I know it's going to be structurally independent? What's the code require for structural independence? And you're going to call them back or email them back and say, well, guess what? It's not in the code. That's your job. You're the structural engineer. So the structural engineer overbeefs that wall. Am I close to what you deal with? Overbeefs it all the time. So design teams got upset about that years ago and said, we can't afford that. It's ridiculous. It does not lend to good design. So what they did is they come up with their own answer to the problem. The code didn't. The code is still out there. And the answer to the problem was, let's create a double wall firewall. And let's connect everything to one side and connect everything on the other side to that wall. And then if there's collapse, right, one wall goes down, either or, correct? Am I there? Okay. I was serving on a committee at LA City, and this issue used to come up all the time. And there's nothing in the code about double wall firewall, particularly how to design it. The only thing you'll find on a standard firewall, single wall firewall, is you'll find 2 details in the code commentary. Both of those details are at the roof line, and those details essentially are nothing but gyp. Do you know who gave those details to the guy that wrote the commentary? Yeah, Gypsum Wallboard Company. That's why those details are full of gyp. So they're not definitive to help you understand how to design that structural wall. So here's what happened. At LA City, we found our favorite architectural rendering of a double wall firewall, and we cut the top off of it and put the LA City letterhead on it, and we handed that to all of our plan reviewers and said, this is how you determine if it's a legitimate double wall firewall. And to this day, it's that way. Because 221 doesn't take the water to the end of the row. Now, let me quickly tell you. A double wall firewall is considered by code to be a single assembly. It's just a configuration of the firewall assembly. NFPA 221 will tell you if you want a 2-hour double wall firewall, you can do it with 2 1-hour walls. Don't do that. You want to do it with 2 2-hour walls. If one wall fails, what do you got left? 1 hour. You don't have 2 hours anymore. There's an argument that by that time you don't need the 2, but I'm going to address that in a minute. The point is that it needs to be 2 hours. Once it's a single wall, when you put an opening in that wall, you carry the rating through the opening, correct? So everything about it, the door frame, everything is going to be rated the same. It's going to be rated 2 hours. So it makes no sense. Now, take it a step further. Once that fire develops in there, there's some key language in 706. That key language says that it has to be structurally independent. At when? At the point of collapse of the structure. Now let me ask you this. If you have a 4-hour firewall, you put a 3-hour opening protective in it on one side or the other, you carry the rating through the opening, right? For 4 hours, the wall is supposed to structurally remain in place and fall under 119 and not transfer heat for 4 hours, correct? All right. Then what happens after that is as soon as that building goes into alarm, what are all the building occupants going to do? They're going to exit the building. Now, just on paper, you've got 3 hours to depend on that opening protective, don't you? If it's in the path of required egress. So it's going to do its job for 3 hours. Okay, by the time all that happens, number one, everybody's out of the building. Number two, where's the fire if the building is at the point of collapse? Everywhere. It goes over the top, goes around the side, it goes everywhere. In fact, the question is, where isn't the fire? So let me ask you, at the point of collapse, do we care about a second door somewhere? It has absolutely no value. Now, I teach this to building and fire officials. I've only had one situation in the last 20 years, more than that, where someone disagrees and says, no, we're going to have 2 doors. Once they get it, it's an easy answer. So if you struggle with that, we can help you with that and resolve that problem. I've written that letter a gazillion times, okay? So understand that on the, boy, you know, I'm going to be in big trouble because they're recording this. And the people that approve the course are going to take this recording and compare it to what I submitted, and they're going to go, boy, that name's hauntingly familiar. All right, so when we talk about the firewall, we're talking about being structurally independent. I think that whole explanation helps us understand that we don't care about the structural independence until when? Till the building goes into collapse, then that better remain standing. What about opening protectives? What can you do there, and how does that work? So when we take a look at opening protectives, then we realize that there's some rules. So go to page 108 and take a look at those rules. I'm sorry we haven't been in there enough. But that's what we need to take a look at, okay? There's 2 different rules there. What's the first one? What's the first rule? What's that? An opening in a firewall with an opening protective cannot exceed what? 156 square feet. Okay, where does that come from? That's what I thought. All right, let me help you understand the 156 square foot rule, okay? Several years ago in a code development hearing, someone came to the table, a group came to the table. They were representing some industry. They came to the code hearings and they said, we think door openings should be limited to 156 square feet. Now their vision was largely swing doors, okay? But why do you think they limited it to 156 square feet? Why would they do that? Say that again? Corridor, okay, what else? Guess what the largest furnace tests? The largest test furnace in the United States in any accredited laboratory is 156 square feet. No, UL's got several, Intertech's got several. Any accredited laboratory, that's the size of the furnace. Now, they'll let you test larger, but you got to pay to build the building to test it in. Nobody's going to do that, right? So this group, believe it or not, they came to the hearings. That happens all the time. They came to the hearings with this very narrow view of all of this. And they said, we think the code should never allow a door to be bigger than what was tested. Now, at the outset, that makes sense, doesn't it? But you jump into 716 and you learn all about oversize, right? Or in other words, what you do is you test in the laboratory, and those FPEs in there take all that criteria, and they determine that if you build it out of the same material and the same components as far as configuration and construction of that particular opening protective, it can be this much larger or that much larger. That's what they're there for. It's called oversized labeling. Now, to give you an idea, as you thumb through this booklet later, and what you'll find is that we, out of roughly probably close to 40 fire-rated wide-span opening protectives that we manufacture, every one of them is given unlimited height and unlimited width by UL because of their robustness, okay? And they're obviously not limited to swing doors. There are all kinds of assemblies, right? They didn't do any of that homework. They came to the hearings with all of that, and that's what they said. And so the 13 on the rostrum are listening to all the testimony. They'd already made up their mind before they got to the hearings, because each one of them is assigned a block of code changes to make the first motion on, whether they understand it or not. And so so we all testified. We made sure everybody understood. No. In fact, I don't know if you're aware, but 85% of what goes out our doors is all oversized. The only problem that you have with oversized is not the assembly itself or the test criteria, it's where you're locating it. If you're locating it in a precarious spot where you might have other openings, then that's when you have to start looking at the size of the openings in case one of them won't close. You have some fire officials, code officials don't care about that, but fire officials do. And that becomes an issue for them. But other than that, no, it doesn't matter. So guess what? Everybody could see the committee was tossed. They didn't know for sure what to do. Empirical data and evidence was not submitted. It's just whatever these folks brought with their code change as far as supporting discussion and supporting arguments. And so guess what? A friendly amendment was tossed out. What was the friendly amendment? That's right. So in that language, you'll notice that in a non-sprinklered building, the 156 stays for no unearthly good reason, and anything over 156 is allowable if you sprinkle the building. Aren't you just having fun learning how this stuff got here? You know, I know you assumed that was the case, but you didn't know for sure, did you? Yeah. That's how that got in the code, okay? Now, what about the next rule that's up there? The 25% rule. How did that get there? You go, well, tell us, Dave. Yeah, the way the 25% rule got there is basically arbitrary. Now, we're talking about firewalls that are structurally independent that delineate or differentiate between structures. So in other words, we're giving away the area allowance for this wall. So this wall is critical and important. So in a firewall, the rules are all their own. They're different than the other walls. And so here we learn in the 25% rule, you cannot exceed it. In the old legacy code, you could under certain circumstances. But in the IBC and the Florida Building Code, you cannot exceed the 25% rule. Here's why. Fire protection engineers are willing to give away, let's use an example. Let's assume all of that, fire rated, and we've got this opening, and this opening exceeds 25%. No, let's say it meets the 25%. Now, by the way, it's a length dimension. It's not an area dimension. It's a length dimension. What's that? Not 25% of the length of the wall. Yeah. Now, some of that changed in the 24 edition of the IBC. I don't know if FBC will pick it up, but some of that changed. Why? Because in NFPA 101, it's a square foot dimension. I wish I had time to tell you all the reasons why, because it would make sense to you about why it's a length dimension, but it's critical and important. So it's a length dimension, okay? So in a 100-foot wall, you can have 25% open. Fire protection engineers are willing to give away 25% of that wall during a fire. That's why you can't fudge. I have design teams in years past would always ask me, hey Dave, what if we put in a water curtain? What if we do this? What if we do that? Can we open that up 30%, 40%, 50%? No, can't do it in your current Florida Building Code or the IBC, and that's the reason, is because the 25% is arbitrary, and because it's very borderline of we don't know for sure we really want to do that, but we'll give away 25%, then there's no fudging on that 25%. That's important and critical to remember, okay? Now, we want to go back to this concept of the firewall, or the fire resistance rating versus the opening protection rating. We learned when we examined this test criteria for opening protectives that those opening protectives are going to transfer heat all day long. It doesn't make sense that if you're going to open that wall that is 250F, this wall over here, it's 250F, then you would think that the opening protective you're going to put in there logically should do the same thing if you're going to fix that hole in the wall, right? Code-wise. But you don't have to. You can put in an opening protective that radiates and transfers heat all day long. Question is, why? And by the way, I always teach building and fire officials, hey, learn to be a 2-year-old. Learn to ask why. And when you get an answer, go why. And go all the way back as far as you can until you can get your head around all the reasons. If you can do that, it's a lot easier, especially for you at the counter. See, when you go walking in and you've prepared an alternate methods and you want approval on that, you need to understand and know what you're talking about. Now, a lot of you, especially on larger projects, use code consultants, and that's what you should do. But they too need to do the same thing, and they're pretty good at it. And that is, we're doing this because this, and we're doing that because of this, and we're doing this because of that. In other words, you have to have a trail to show that the alternate methods is equal to the intended purpose of that code language. That's what 104.11 is talking about. Okay? So you have to be sure that you can justify what you're talking about. So let me help you so it makes a little more sense. Why wouldn't you require that door to be rated the same as the wall? Say that louder. He's exactly correct. There's no combustibles in front of the door. If you were to go to work right now in the workplace and put all your personal belongings in the doorway, how long would you work there? Doesn't work, does it? In other words, because of the doorway, what we're going to find is that you're not going to put things there. Now, why don't we address what's on the screen? That's coming next. Okay? Swing doors, and the reason for the 25% opening, let me finish that segment. The reason for the 25% is this: the door will probably not close anyway. Yeah. In a fire, that's why they're willing to give away that 25%. That's the last segment of that. They feel like that the door's not going to close anyway. What do you see for a failure rate on swing doors on the screen? Yeah, I usually go through a guessing game. We don't have time for that, but everybody guesses, failure of swing doors, which is the conventional answer for any, they always close. Nope, they have an 86% failure rate. Watch the screen. Here's why. Yeah, if you take a 2x4 that long, cut it on a diagonal, you can get 2 in one cut. That's right. You can create door stops all day long. That's the problem, those door stops. The beautiful part about wide span opening protectives is that you can't chalk them open. Our failure rate's about 2%. And it only has to do with batteries and electronics sometimes. And we cured that out of 37 different technologies. Only one of them closes with a battery. All the rest close mechanically. They will always close, okay? So that's the reason. Now, let's take a look then at this issue we were talking about. I'll just flesh it. Whoop, what's going on here? I'll just flesh it out so that you can see it. You cannot put combustibles, as you said, in front of the doorway. So for that reason, then the doors don't have to be rated same as the wall. Okay? Now, let's talk about an application here, and then I'm going to take you to another application to illustrate shaft enclosures after this one, and then we'll tie up and be out of here. We got 20 minutes. It's kind of funny. I thought about standing up here and saying, it's Sunday. What are you doing here? Would you please all open up to Matthew 26, and we'll catch up. I said it. I told myself, don't do it. Don't do it in this new society. Don't say it. It's being recorded. All right, so here's what happens. As soon as you walk into an architect's office as an owner of a structure, what's the primary question that you're asking that owner before ink hits blotter or pen hits paper? You know what? I've never been good at multitasking. And my hearing aids are going, whoa. So shout out just one at a time. What's the first question? How much? Yeah. You want to know how much money they got, right? And it's not to pay your staff, although that's a good idea, right? It's not to pay the staff, it's to what? It's to determine what? That's right. What construction type? Wouldn't you all love to design to 1A? It's a breeze, isn't it? Okay? But we all know the restraints on the pocketbook. And so everybody wants the biggest bang for the smallest buck, right? It's always the case. And so construction type comes into the issue. And this is what I learned way back in 1988 as I began to realize, hey, wait a minute. We got to understand what the challenges are. We got to understand what's being talked about in that back room back there long before that building ever gets drawn. And obviously, it's this issue. And so let's take an example. So up on the screen, I keep forgetting these are down here for me. But here's what you see. Somebody wants to build a multiplex theater. We see those all the time, right? No big deal. They come in and they say, well, I've got X amount of dollars. I got to get an ROI. The bank wants money back, by this date, and They go on and on and on. And at the end of the day, what they're really trying to do, or what they're saying to you, is they're defining your parameters as to what the construction type is going to be initially. Eventually, you're going to get into the other expensive items, but right now, the most expensive is that construction type. And so they explain to you essentially what they need. So you end up telling them, well, that's an A1, and by the way, we could probably do that as 3B or even 3A construction. We're going to end up at 34,000 square feet, though, whatever we choose. We're going to end up at 34,000 square feet as a maximum allowance. That's what we have to work with. They go, well, why? And so you feebly try to explain to them, well, the code won't allow us to go any bigger unless we increase the cost of construction, right? In simple terms. So that begins the discussion. You were the hero because you won the bid, and now you're the design team. But very quickly in this discussion, you're going to start to not be the hero anymore, right? You're going to have to start giving them all these parameters and rules and codes to tell them, no, these are our limitations. What a challenge, what a problem. So this never happens, I know to you, but in these seminars, I try to teach you a new phenomenon, and that is that owners can change their mind. Happens every day. It happens before it happens, doesn't it? Yeah, it just constantly is an issue. So this owner goes away and thinks about all this, sits down with the investors and friends and whoever else they're talking to, and they figure out that they want it to be bigger at the same cost, right? So they sit down with you and you kindly explain this phenomenon to them. Look, I told you we're limited to 34,000 square feet. If you want to do what you just told me, then we got to go to 1A or 1B or maybe 2A or 2E, even 2B, right? But in order to meet their new request, it's going to cost a lot more money. And of course, that's where, you're not the hero anymore, right? So we can't build everything to 1A, so how do we do it? We come in with firewalls. That's the give me. That's what the code allows you as a choice to make. So you come in with a firewall, and here's why. It's pretty simple. You can put 3 separate structures under one roof, right? What's the problem with the firewall? Tell me. Design-wise, what? Yeah, it's not cost, really. Louder? Structural independence, yeah. But that's overcome, that's not a lot more than what you're going to do with that wall anyway, honestly, cost-wise. I've run those numbers. It's not bad. The biggest problem is what? You're closing it down, aren't you? Yeah. And you know what you learn in school? You know what you learn in school? Sheetrock and swing doors. Yeah. Well, let me introduce you to a couple of ideas that might help you, because this is confining, right? So what about this? What if you just open those up? You might be saying, oh, Dave, what about the 25% rule? I got you. See those little extenders? Those walls go forever. So in other words, you can open those areas up only to close in case of fire. And there's a lot of different options to be able to do that, because it can come down from the ceiling, it can come from the wall, it can come horizontally across, it can be stacked in a very narrow 7-inch space, or it can be stacked in a 20-inch space, whatever. There's all kinds of different options for you to be able to do that. That's not the point of the discussion. The point of the discussion is this. If you look up on the screen, this is that project many, many years ago. This took place in LA City. The same rules in the FBC apply here. And let me share with you what happened, because I think it's very critical for you to understand. You can see on the screen in the clouded areas, right, where the swing doors and mullions are. You see those? Okay. Those swing doors and mullions were the original design. I sat down as a young punk with a friend of mine in the fire department at LA City, a great guy. By the way, he was working in the fire department at LA City while he got his degree in architecture. When he graduated with his degree in architecture, he loved what he was doing as a fireman, and he just stayed there as a plan checker fireman the rest of his career. Not sure about that, but that's what he did. Great guy. So what happened is I was well prepared to go in and say, I'm going to come into you with something that is wide span opening that's going to open differently than a swing door. Barely in the code, new concept. I was well prepared to spend about an hour and a half helping him understand that this is approvable. I mean, I was ready to fight the demagogue. First thing out of his mouth, he said, Dave, why are those swing doors in there? Because I had both drawings. He said, why are those swing doors in there? I said, well, that's what we need to talk about. I want to take those away. He goes, thank heaven. I go, what are you talking about? He said, when you get an assembly occupancy and you have lots of folks hitting that door, exiting that building in a fire emergency, you've created a roadblock, an obstacle. They're going to hit those mullions. The people are just going to pile up there. What do you want to do? I said, I think you already know. He said, yeah. He said, show it to me. You'd hit that wide span opening protective. It opens all the way up into the wall, and now you have all this free space for everybody to exit. It's going to wait 3 to 5 seconds and start to reclose, and as you touch it again, it's going to open to full open. He said, I love it. So keep that in mind, that conventional swings and mullions are not always the best answer. And that's an issue to think about. Now, the fire barrier wall, and this is where we've got 10 minutes. Are you okay? Are you hanging on? All right. If you got to go to the bathroom, you can go, but we'll all watch you as you go. Okay? But when it flushes, it's down the hall, we won't hear it. All right. Now, when we talk about the fire barrier wall, the rules change. The 156 rule is the same. All of that's the same. But when it comes to the 25% rule, you can exceed the 25% rule if the opening protective is rated 119, the same as the wall. That's the difference between the fire barrier wall and the fire wall. You with me? Okay. Now, those opening protective guidelines are on page 109, and that's where you're going to see that detailed for you. Now, let me show you something, and this is important for us to understand. It'll help you understand code development better. It'll help, and by the way, the FBC picked up the same language. No one exempted it or stopped it. So I want to go through this with you to be sure that you understand, okay? If you look at the top paragraph, we're talking about what we've already talked about, the 156 and the 25% rule. Now, if you look at the first exception, and I have to stop here and quickly tell you this. What is an exception in the code? Let me shortcut it because we're out of time. An exception is not a workaround. An exception is not an exception to the rule. The charging language that you see, when everybody sees an exception below it, they think the charging language is the mandate, and the exception is if you can't do anything else, then you can do this. That is total hogwash. When I start a seminar with building and fire officials, I address this issue first before we go through a whole day seminar. And here's why. None of them go to the hearings. They don't get it. They don't know. And that's why across the counter they'll look at you and say, I don't know if we can accept that. We're going to have to talk about it. We'll get back to you. When you use an exception to justify what you just designed, some configuration or whatever. An exception is not an exception to the rule. An exception is a rewrite of the charging language, and it's as binding, if not more binding, than the original language. Think about the code development process. We rewrite the code every 3 years. Can you imagine if we took that charging language and just changed that narrative again and again and again? You'd end up with a novel that makes no sense. You're not sure what you're got to do or design to. So what we do is we make all the code changes to the charging language. I'm going to fall off of here, aren't I? A bullet list. And that bullet list is titled exception. That's the problem. It's semantics. It should never be called that. We've tried to change that, and we can't get anywhere with it. It should say change or amendment or whatever. But it doesn't. It says exception. So the human nature is it's an exception to the rule. It's not. So when we go in and put in new language, we call it an exception. It's as binding or more binding than the original. Are you with me? Okay, don't forget that. And I guarantee you that the plan reviewer that you're talking to is not going to get it. I teach them on a daily basis. I know. I run this by them. I've done it for 20-some years. I run it by them, and they all come up with the same. We take about a half hour, and they all describe an exception, all the way from, well, a workaround. We don't like it, but we'll let you do it. They give me all those definitions. So don't feel like the Lone Ranger, but you are. They don't get it. Okay, so that exception says, oh, by the way, openings shall not be limited to 156 square feet where the adjoining floor areas are equipped throughout with a sprinkler system. Okay, we discussed that one. But look at exception 2. Openings shall not be limited to either of those rules where the opening protective is a fire door serving enclosures for exit access stairways and ramps and interior exit stairways. Now I want you to read that again. Can you read it for the most part up here? Okay, maybe way in the back you may not be able to. Okay, but tell me what that's saying. It's clear as a bell, isn't it? Have any of you used this exception? When you're designing a university and you have a required exit stair that opens into a floor where you want the students to be able to see where they can go, or open literally into a classroom sometime. An exit access stairway, right? Have you ever used this exception to be able to have that wide open and not have the 4 walls of the enclosure? Well, what does it say? It says you can. Wow. It says, let me read it to you, okay? The 25% rule, the 156 rule, it all goes away because it says shall not be limited to those where the opening protective is a fire door serving enclosures for exit access stairways, ramps, and interior exit stairways and ramps. Is it any clearer than that? Why can't you do it? How'd that code change come about? Let me show you an example on the screens here. These are cut and paste, obviously, aren't they? Because they're real examples. Okay, look at the wall where the door is on both examples. Does that door opening exceed 25% of that wall? Yeah, in some cases more. So the code official that submitted this, believe it or not, came to the table, came to the hearings and said, I'm tired of approving this when it goes against the code. Because that door opening is exceeding 25% of that wall. Therefore, I want this code change to remedy that problem. Well, everybody had empathy for his problem because everybody faces that at the counter, right? And they said, you're right. So that language, you can see it again, is written right there. So now you're not breaking the rule every time you approve one of those doors in that short wall. Are you totally confused now? I hope you are. Okay, take a look at this. All right, when we talk about that shaft wall, where does the rating start and where does the rating end? Can you design a wall that can turn a 90-degree corner and maintain its rating? Stupid question, isn't it? That's Architecture 101. Well, of course you can. The rating of the wall is an aggregate value of all four pieces together because it's a running length of rated wall, for pity's sakes. The 25% rule applies to the entire length of the rating. What do we call it in the code in 703? Continuity. Fire rating continuity, right? I walked in. had taken a break. I was outside and walked in at the end of this code change, and it was too late. I talked to one of my buddies. I said, why didn't you stand up? Why didn't you talk about it? Well, I didn't want to get embarrassed. Well, the code change passed. You know how many people's called me and said, hey, Dave, we can take a required exit stair. We can open that thing up as much as we want now. Well, exception 2, I go try it. Go try it. Because that person over the counter in their right mind is never going to approve that, okay? So this guy was looking at it this way. He said that short wall is where the 25% is to be measured from. That's the length of the wall that we're talking about, right? No. This is what we're talking about. All right. We're about a third of the way through. Hey, listen, we've got 1 minute, actually 40 seconds. Any questions, burning questions? You know, last speaker, last day, I dare you to ask a question. You've been great, thank you.